Hi Year 11s and welcome to this special edition of General Maths. I do apologize that I'm not there today as I am marking Year 12 SACs with the other Year 12 teachers, and so in place of me teaching the class as usual, I hope that this video will be enough for you to get going with the exercise. It's pretty straightforward. I have no concerns that you won't be able to follow this lesson. What we're looking at today is matrices as mathematical objects. So we're now going to ask, when are two matrices equal? What happens if we add two matrices? And what happens if we multiply a matrix by a number? So we'll begin by asking the question of equality. When we write the equals sign, we're saying that the objects on the left and right are the same. And for a matrix, what we want is for the matrices to have the same order. So those are the dimensions. And we want every number in the same position to be equal. So let's look at some examples. In this first one, I have a matrix that has order 2 by 2. Remember, order is written by number of rows times number of columns. The matrix B has 2 rows and 1 column, so the order is 2 times 1. The orders are different, so not equal. So this statement is false. Even though the numbers 1 and 3 are the same, the matrices are not identical. All right, for the second one, I have the matrix 5, 6, 7, 8 for C and 5, 6, 7, 9 for D. Question is, does C equals D? And the feature that I want you to notice here is that the numbers 8 and 9 are not the same. So the way I could write this mathematically is I could say C22 equals 8 and D22 equals 9. Remember, C22 means the number in row 2, column 2, and D22 refers to the same position, but in matrix D rather than C. Since C22 is not the same as D22, the matrices are not equal. So I've shown that there's a different element. So this statement is also false as well. Okay, next example. So I've got the matrix 10, 20, 30, 40 for E and 10, 20, 30, 40 for F. Question, does E equal F? Now, for the first time, we have a situation where the orders are the same and all of the numbers in the same position are the same as well. So yes. And the way we could write this mathematically is Eij equals Fij for all I and j. So E11 equals F11, E12 equals F12, and so on. So the matrices are equal. It's also worth noting that E and F have the same order as well. All right, next example. So I've got the matrix 10, 20, 30x for G and 10, 20, y, 40 for H. And I've stated, this time, not as a question, I've given you the statement, G and H represent the same matrix. So I want to find those values. So what you should notice is the number 30 and the number y are in the same position. The number x and the number 40 are in the same position as well. So mathematically what I could write is G21 equals H21. And so X equals 30. Sorry, Y equals 30. And I could also say G22 equals H22, and therefore X equals 40. You might feel that I've written a lot for these questions. If you just wrote the answer, that would be fine. But I'm trying to show you the reasoning that's underneath all of this as well. Okay, so if you just wrote no, no, yes, 30, 40, that's fine. Okay, next example. Next concept, I should say. So now, for the first time, we're going to do calculations that involve combining matrices together. What we want to do here is define addition and subtraction for matrices. And it's very simple. All we need to do is first check that the matrices have the same order, that they've got the same dimensions. If this is not the case, then we say addition and subtraction is undefined. How do we add two matrices? Well, all we need to do is add numbers in the same position to create the new number in that position. And I think it's easiest to do this with examples, but if you want a mathematical definition, I could write it for you. So if C equals A plus B, then the number in row I column J of matrix C is the same as the number in row I column J of matrix A plus the number in row I column J of matrix B for all possible values of I and J. And this assuming that A and B have the same order. Okay, you don't need to know that, but that's the way addition will be defined if you take more maths after leaving school and you work with matrices. So it doesn't hurt to see it once. But I digress. Let's do some examples. Okay, so with this first example here, I've got a 2 by 2 matrix plus another 2 by 2 matrix, and so I first check, do the matrices have the same order? Yes, they do. That means it's possible to add the two matrices. How do we add them? To get row 1, column 1, I'm going to do 1 plus 5. To get row 1, column 2, 2 plus 6. Row 2, column 1, 3 plus 7. Row 2, column 2, 4 plus 8. So what you should see is I'm adding the numbers in the same position to get the resulting number in that position for the final matrix. So our final answer is 6, 8, 10, 12. For the second example, so you'll notice this question says where possible. You should be seeing that we have a different case here. This is undefined. Why? Because the matrices don't have the same order. And if you wanted to be more specific, you could say the first matrix on the left has order 2 by 2, 2 rows and 2 columns, whereas the second matrix has 2 rows and 1 column, so we would say the order is 2 times 1. All right, for this third example here, I've got the matrix 3 minus 5, take away, minus 4, 9. So just like addition, what we're going to do is check, do the matrices have the same order? Yes, they're both 2 by 1 matrices. And we're going to do subtraction this time by matching the positions. So my first number is going to be 3 minus -4. And the second number is going to be -5 minus 9. And the reason why I put brackets here is because I'm showing that I'm subtracting a number. You don't have to do that, but I prefer to do that. When I subtract a negative number, it's the same as adding the positive version of that number. And so my final answer is going to be 7, -14. Okay, very straightforward. All you need to do for addition and subtraction is to match the positions in the matrices and then do the addition and subtraction like you normally would. Okay, one more operation. Scalar multiplication. Now, the word scalar might not mean anything to you. For our purposes, you can just think of a scalar as a number. It can be positive, 0, or negative. There's no restriction on the number. If you're taking physics, you'll learn about something called a vector. A matrix is a, well, I shouldn't say a matrix is a vector, but a vector is a kind of matrix. So the reason why we've given this a term is because there are actually two types of quantities for multiplication. We can do scalar multiplication, and this is where we have a number that is the scalar times a matrix. And in the next lesson, which is not today, we will do what's called matrix multiplication. And this is where we're going to take a matrix times another matrix. And that's a very powerful thing to do that makes this whole topic worth studying in the first place. Because right now, we've basically just got tables and grids of numbers. They're not very interesting. But once we define this in the next lesson, the scope of what we can do is going to become very large. So hang tight for that. For now, we will content ourselves with simply multiplying a matrix by a number, and it's very easy to do. All we've got to do is take that scalar, take that number, and multiply every number inside the matrix by that number. So, for example, if I give you this matrix capital A as 1, 2, 3, 4, and I want to calculate 10 times A, in this instance, 10 would be the scalar. And you can write 10A, or you could write 10 times A. But just like with algebra, if I don't write the multiplication sign, it's sort of implied in this case. So 10A would be equal to 10 times 1, 10 times 2, 10 times 3, 10 times 4. So notice every number inside the matrix is keeping its position, and it's getting multiplied by the scalar on the outside. So I'm left with 10, 20, 30, 40. That's my answer. All right, for the second example, what's happening here is I have multiplied by some number k. I haven't told you what it is. And I've told you that that's equal to -5, -10, -15, -20. Question, what value of k gets me from this matrix to this matrix? And you can probably see it by inspection, but if you're having trouble seeing it, if I multiply the matrix A by k, I will now have k2, k3, k4, k. And this equals -5, -10, -15, -20. From which we can conclude Since these two matrices are equal, that tells me that this number equals this number equals this number, and so on. And so here, it's fine to just write the answer. We can say k equals -5. All right, one more example, and I'll do a quick CAS demo as well. So what I want you to notice here is I have combined scalar multiplication with addition and subtraction. Might look intimidating, but it really isn't. All we need to do is do the scalar multiplication first, and then do the addition and subtraction. Now, for this exercise, I think you should do the calculations by hand to develop your understanding of how matrices work. Once it gets tedious, or once you have finished this exercise, I am happy for you to use your calculator for the rest of the chapter. But for now, let's do this one by hand. So what I've done is I've replaced A, B, and C with their respective matrices, and I've written the scalar out on the left. Remember, when I write a number to the left of a matrix, this means scalar multiplication. So next I will have 3 times 4, 3 times 5, minus 2 times 2, 2 times -3, plus 4 times -1, and 4 times 7. So here I have shown what's happening with the scalar multiplication. Eventually, you'll be able to skip this step and go straight here. All right, so we'll do that calculation. And we can combine everything into one matrix. So the top row will be 12 minus 4 minus 4. And the bottom row will be 15 plus 6 plus 28. This is a plus because I've got minus and minus here. 12 minus 8 gives me 4. 21 plus 28 gives me 49. Okay? Now, let's quickly do this with the CAS calculator. So I'll start with the class pad. So on the class pad, to get a matrix, click on keyboard, Math2, and you will see 3 buttons that you can press to enter matrices. Now, in this particular instance, our matrix is a 2x1 matrix, so we can just press this button here. Press enter, and there we are. Got the same answer. Now, when you do the exercise, you might get matrices with different sizes. So here's a hint. So if I want to make a square matrix, I click on this 3rd button here. And I can press the button again if I want to enlarge the size of the square. Alternatively, I can press the 1st button to add columns and the 2nd button to add rows. So have a fiddle with that until you're familiar with how to get matrices into the CAS. On the TI, it's very similar. So this time what you want to do is go to the main application, go to calculator, and to get the matrix interface, you need to press this button to the left of the book. And again, there are 3 pre-built matrices ready for you to go. If you don't want those sizes, you can click the 4th option with the 3x3 grid and tell the CAS what size you want your matrix to be. So we don't need to do this, but I'm just showing you how it works. So there's our first matrix. And then here I'll just do it the normal way with the pre-built matrix there. -1 and 7. And we get the same answer. Okay, so regardless of whether you are using the ClassPad or the CAS, what I encourage you to do is to make sure that you know how to do these calculations by hand and how to do them on the CAS as well. If you've got any questions, feel free to send me a message on Teams and I'll get back to you. All right, so thanks everyone, and I look forward to seeing you later this week.